Before we get into solving equations and problems using algebra, we have to go back to a very basic principle here, and that is that an equation has an equal sign in it, which serves as a balance point between two sides. So basically what it's saying is that one side of the equation over here has the exact same weight as the other side of the equation. And we also know that when we use variables, we can simply replace that box with 3 plus any number, which obviously equals the other side. And we say that this is now in balance. The other thing that we need to realize too is that if we change one of the two sides in any way, then we must do it to both sides in order to maintain the balance. For example, if I were to say, you know what, I don't want to put the 3 in here anymore, I want to take it away. Well, what's going to happen is that this balance point is going to shift, because now we're going to have this side of the equation weighing more than this side of the equation. And so in order for it to get back into balance, we would have to take away 3 from this side in order to bring it back into balance. And that's a very important concept that we need to be able to understand before we can move forward. Okay, let's take a look at a very typical problem that would you could use algebra to solve. Okay, so in this case here, we've got a situation where the fair is in town. All right, yay, fair's in town. So what we're going to do is we're going to take a look at a couple things. Now, one of the things that we've found out is that the costs of going to the fair, it's $5 for general admission. So $5 to get in. So we'll say admission is $5. And then rides are $2 a ticket. So we can simply say that what we have here is a very easy way of looking at an algebraic expression, because we don't know yet just how much this is going to cost, because it's dependent on the number of rides that we're going to go on. But we know that for each ride that we go on, we're going to be charged $2. So if we went on 3 rides, it would simply be 2 times the 3 rides to get us our final answer. But what we can do, though, is write an algebraic expression out of this. And that algebraic expression is simply this, is that the total cost of this of going to the fair is going to be 2 times, we're going to say n, because we're going to let n equal the number of rides. Okay? And so we're going to say 2n plus the $5 that we're going to have to pay no matter what, because that's general admission over here. And that would be our constant term, is going to be our expression. This is going to be our expression, because no matter how many rides I go on, I can still use this to solve it. And just to prove it, what we can say is, all right, well, let's say, for example, we went on 5 rides while we were there. So then what we would do is we'd simply plug in 5 for n. So we'd say 2 times 5 plus 5 equals. And then we just solve for n here, which we've got 10 plus 5, and it costs us a total of $15. So that is our expression being used in a very practical way. But what if we were given a problem where we knew how much money we spent, but we didn't know how many rides we went on? Let's take a look at that. All right, so now we've got our expression here, 2n plus 5. Okay, that's our expression so far for what we're going to be doing with regards to going to the fair. But say at the end of the night, we realize that we spent $21. So what we can say is that our $21 that we spent was equal to 2 times the number of rides plus the $5 of admission. Now we have ourselves an algebraic equation because We've got two sides here that, and we've got an equal sign in the middle. Just write this down a little bit. Plus 5 equals 21. All right, now, where do we go from here? Well, if you remember back to when we did integers, we remembered the concept of zero pairs. And one of the first steps that we want to do is we want to get n by itself. So what we're going to do for starters, we're going to look to see if there are any constant terms that we can eliminate by using a concept of zero pair. Well, we know that if we had 5 here and we wanted to get rid of that 5, all we would have to do is subtract 5. But if we were going to do that to one side, we know that's going to tip the equation, the weight of the equation. So in order to maintain the balance between this side of the equation and this side of the equation, we have to also subtract 5 from the other side. So now we know that's zero paired out, so that's gone. And now we can say that 2n must equal 16. All right, so now we have 2 times a number must equal 16. Well, remember, we want to get n by itself. And what 2 times n actually means, it was 2 times a number. And the opposite of multiplication, and the way that we're going to zero that out, is simply by dividing. And remember, this line here means divide. So if we both divide what we do to one side, we have to do to the other. So 2 times 2 is going to, or 2 divided by 2 is going to cancel that out. And what that means is that those 2's cancel each other out. We're left with n, and 16 divided by 2 is equal to 8. So what we can say is that we went on 8 rides. So therefore, we went on 8 rides. And just to double check that, we can actually plug 8 back into the original equation just to make sure that that actually works. So we'd say 2 times 8 plus 5 has to equal 21. Well, 2 times 8 is 16, and 16 plus 5 equals 21. Of course, we got some crafty students here, and when we got to the end of that last equation, they pointed out a couple things. First of all, when we divide over here, we notice that these two cancel each other out, but they said, hey, Mr. Kersey, 2 divided by 2, that's the same as 2 over 2. That's the same as saying 1 whole. So shouldn't this answer, in fact, be 1n equals 8? And the answer is yes. It really should be. But the reason that we don't put it in is because simply that 1 times any number is going to equal the number. And what we're saying here is that 1 times a number equals 8, which means that 8 is in fact that number. So 1 times any number is going to be the same. So we just don't actually write it in, okay? Because, like I said, 1 times 8 is going to be 8. All right, let's look at one last basic equation here. And we're not going to get into too much depth with this stuff this year, but I just wanted to give you a real brief introduction to it so that it won't be totally foreign to you when you get to high school next year. All right, so we got it here, 4n minus 3 equals 13. So let's go back through and figure out how to calculate this. So the first objective, obviously, is to get n by itself. So get n alone. All right, good enough. So we're going to start off by using our zero pairs here. We've got a constant here, a constant term of 3. So what we've got here, though, is our operation is subtract. So what we're going to do is we're actually going to add. We're going to do the opposite. And a lot of solving these equations is, in fact, doing the opposite. So we've added 3 here. Our equation is now out of balance. We must also add 3 here. So good. Now we have canceled that out. That's a zero pair. is minus 3 and plus 3, or positive 3 are going to be 0. So now what we're left with is 4n has to equal, well, 13 plus 3 is 16. So now what we've got is we've got 4 times a number equals 16. So in order to get n by itself, we have to do the opposite of multiplication, which is to divide. And remember, this line means divide, and we divide both sides by 4, because if we're dividing this one by 4, we also have to divide this one by 4. We know those cancel each other out because that's going to give us 1, and that means n is going to equal 4.